Example 3.2. In example 3.1, that's previous question, the electron drift speed is estimated to be only a few millimeter per second for currents in the range of few amperes. How then is current established almost the instant a circuit is closed? I hope the question is clear. When you close the circuit, immediately you're able to see the current. How is it possible? But the drift velocity of electron is few millimeter per second. Okay. That is, current appears almost instantly. Why? That is, drift speed of electron is very small, but when a circuit is closed, electric field is established almost instantly throughout the conductor at the same speed of light. Electric field developed almost everywhere with the speed of light 3 into 10 to the power 8 meter per second. This field makes the electrons start drifting everywhere. So even though electron is moving, the drift speed of electron is millimeter per second, when you are applying the electric field, the speed of electron is very high because of applied field. Applied field velocity is velocity of light. Therefore, current appears immediately. We'll go for the second part of the question. The electron drift arises due to the force experienced by electron in the electric field inside the conductor. But force should cause acceleration. Why then do the electrons acquire a very steady average drift speed? Okay. Why steady drift speed, not continuous acceleration? Why there is no acceleration? Electric field tries to accelerate electron, but what exactly happens? Electrons collide frequently with the ions or nearby ions, lattice structure, all those. So each collision reduces the speed. So whenever electron undergoes collision, its speed reduces. So electron attains a constant average speed. Constant average speed. Third part, C part, electron drift speed is so small and the electron's charge is very small. How can we still get a large amount of current? Okay, we come to the equation. Current mainly depends upon what are the factors? NEAVD, relation between drift velocity and current. N is number of electrons per unit volume. In the question, it is given that drift speed is very, very small. VD value is very, very small. How come the current is very large? Yes, even though VD is very small, number of electrons per unit volume, it is very, very large. Therefore, the product, that is current, becomes very, very large. D part, do all the electrons move in the same direction? When electron drift in a metal from lower to higher potential, does it mean that all electrons in the metal are moving in the same direction? Your answer is no. Why? Electrons have random thermal motion. Drift motion is only a small average shift. Therefore, average total motion is random motion plus slight drift. So, it always never moves in a straight line. We go for part D now. Are the paths of the electrons straight line between successive collision with the positive ions of the metal in the absence of the field as well as in the presence of the field? In other words, we have to discuss the motion of the electron in the presence of field and in the absence of field. Okay. In the absence of field, what happens? Electrons experience no net external force. They have preferred direction of motion. In other words, they will move randomly, move due to thermal energy and undergo frequent collision with the lattice ions. Between two successive collisions, an electron moves in a straight line, but due to repeated collision, its overall path becomes irregular, or you can say zigzag. This happens under the absence of field. Now we'll go for under the presence of field. When you apply the field, what exactly happens? When the electric field is applied, what happens? See, F equal to E into E. E charge of electron, applied field is C. F equal to ma. Now, acceleration A equal to F by m. F value is E by m if you substitute. So, electron has continuous acceleration between collision. Under the presence of electric field, electron gains an acceleration, right? Yes, electron already has random thermal velocity. Now field is added. It's already having random velocity. In addition to that, acceleration is also there. Acceleration in one direction. That is, electron has random velocity plus electric force. So the path becomes curved. Random motion with acceleration, final path will be curved. In the previous case, under the absence of the field, path becomes zigzag. Under the presence of the field, path becomes curved path. I hope it is clear.